then this is need in what we call the investment for the medium and the long term. So, or we also can call short term, but short term is too short, but then we start to look at the medium. So water technology profile, renewable or conventional. So that is also looking for it, but obviously this is what we're more towards sort of renewable. So then the problem will be is if we're using a lot more, everything is renewable, then this, because of renewable, will increase called variable and unpredictable, let's just say the wind and the solar. And then we also said, because if let's just say inflexible nuclear kind of a generation. So what the really sort of a mixture, because if you too much sort of renewable, then system might not be stable, because if it's no wind, there's no generation. If it's too much kind of a nuclear or maybe traditional kind of a gas with carbon capture technology, then it's still need a lot of efforts to do that. So what we said, which obviously we prefer renewable, but at the same time, so what we need is really called system flexibility. So we are talking more and more towards distributed generation, distributed network or microgrid, or maybe at home. So this is what we call need a flexibility. So uncertain primary energy price and the technology cost. This is very important, is because in UK we live quite relative what we call the stable, called flat tariff, relatively cheap compared with what we earn. Okay, so many people don't really concern about that. So they just say, okay, whether we install PV, which costs you maybe £10,000, and then lifetime is about 10 years, then whether we can pay back. Because if I use electricity, I can do exactly the same, but maybe not over 10 years. I maybe only pay about maybe 9,000 or maybe 8,000. So it's not really incentive towards to go to install PV at home. Or but in UK we have relative, because the home, most of the home is more kind of individual, so they can install on a roof very easily, but there's no incentive for them to do that because electricity price is a little bit cheap. But in some other country, obviously there's more kind of a building, more sort of flat, so they cannot do by individually, but at the same time this has to make efforts for whoever manages this kind of what we call the flat, have to make efforts to do that. So then the price maybe make the individual or maybe the community to invest for this kind of new technology. So, but what happened is what we cannot slow down the climate changing. So that's why we have to do something. So one kind of okay, so this is what happened. So now again, this is a kind of classical power system drive. So energy dilemma, what we call. So this is really tied to economics. I think it's very important to look at the economics. So people develop, unless the government give a lot of money to incentive, we call incentive. So in UK PV install in one period, basically the government gave maybe £3,000, and then you pay about £7,000. So kind of incentive. Then they look at it, it's okay, that's fine. So we installed it. So there's a hit another problem. So this is a kind of dilemma, which is so the energy sort of fear, because what happened, we have renewable energy coming. They call intermittency. When the wind blow, no electricity, but wind not blow. Sorry, wind blow plenty, wind not blow, no electricity. So there's a kind of fear. The lights on, and the most important is security. So it's important for a utility to operate as a kind of a secure sort of electricity. They know what exactly happened in every sort of half an hour or an hour, because then they can dispatch this sort of energy and make sure that the any incidents not cause that of a voltage collapse or blackout. We issue this. Then similarly to other aspect is called greedy. So we always said, because especially in UK, the company is private. Okay, if it's a government owned, that's probably less issue. But it's private, then they have to make money. So as soon as they make money, then they have to make sure that what is invested is come back. So this is what we call energy dilemma. Okay, but in other countries, maybe not issue because you actually can, what we call the government put a lot of money. So it's, for example, in Europe, maybe they do that. So now this is another sort of slide, what we call what is the effect of the, probably you all know that, is because when we have the load profile, this is very important. Hello? Okay, so which is very important. Load profile is very important. Is called effect of the cycle demand. So when we have lighter load, which is only most efficient generation, generative probably okay, marginal cost low. So that means when the people plan to that, then they will look at the load. So when the generation would fail or when it's not. So they will, it's a kind of, this is the kind of a perspective, a traditional way to look at it. So you have a lighter load demand, then you look at the generator, what is the efficient generator to use. Then if it's a high load, then need to less efficient generator. So means you have massive kind of generation which is put on. So that when this is a kind of a zigzag or whatever it's called a unit commitment. So basically when the people do planning or national grid operator is planning, they look at the dispatch sort of contract with the generation and with the dispatch. So that is the issue of what we call. So this is really looking the aspect of economics. Okay, so you're looking what the type of generation is good for lighter load or higher load. So there's looking, but then where this kind of renewable generation is fit, that's the question. Okay, so this is another profile which we're looking. Also, this is I look at this perspective of, because I mentioned the distribution network. Now, when you have developed what we call microgrid, and then the first things you need to look at the infrastructure, to look at the network is whether it's fit the purpose, or that network is okay for you to increase whatever you like, because we already installed that network capability based on what is domestic already in there. So when you put a new generation and whatever the customer want to put in, then the network might be not designed for that purpose. So this is the load profile, which we need to understand thoroughly before you start to looking at the microgrid, like I say, because the microgrid will call LV as type of a street or a smart street type of. So you look at the low voltage with the kind of a community in this area, and then everybody want to install their PV or low carbon technology, then they are very disruptive for kind of networks. Okay, so this is what we call profile. So now when we look at profile, this is the profile we take from ENW. Basically, it's Electro Northwest in Limited in Manchester area, which is a very good relation with our university, our group. So we take this kind of, so one profile, which basically say, this is what we call 1.5 million domestic unrestricted customer. So we, for example, our home is falling in this category. So basically we don't care. They have a flat rate of tariff. So customer want to use when we use. So this is a profile, the accumulated to look at what is the profile. So you look at this kind of with a typical domestic, which everybody sleep, then in the morning they pick up, then evening having use. So this is what we call the Then the another one is called profiles class 2. It's called domestic economic 7, which is a really kind of a controlled demand side management. What it means by that is because of the evening in UK we have what we call heat boiler, right? So you boiler, you put this called hot water container for shower, for mainly for heating system, because in UK we live in a relative cold area, so we actually don't have air conditioning. We're normally using a heat, so there's a heat really is a sort of a major energy consumption for us. So what we call domestic economic 7 means that because during evening very little sort of electricity consumption. So in terms of network, they have a lot of electricity free. Otherwise, they have to shut their generation off. So what they do is they basically to put some what we call very low price for electric use. So that means the if you are subscribe this, that they give very maybe half price or even lower the tariff, then you can actually heat your using electricity to heat your sort of a hot water tank. So those are basically as a kind of a storage, so hot water tank storage. Then you can using during the day. So that means the it's almost like I say storage, but then the benefits for the customer basically using very cheap electricity to rather than just in the morning everybody peak price, then you heat using this heat water, which is 3 times or maybe twice much of the electricity price used. So this is also very popular. And then because then the issue is because you need a hot water tank, so which I don't like much at the time, but then because only for shower, then you have if you want to good lots of people living in the home, you need a big hot water tank which occupies space. So if your house is not very big, then so that's why it's only about 200K to 200,000 customer actually using that. So majority people actually not bother. So that is what we call. So this is kind of a diversity. But now in the future, maybe you have a more diversity because this slides really tell you it's called uncontrolled domestic sort of customer, which you call class 1. And then the what we call demand side, controlled demand side. So that is, then people don't like a control because they want to fix. So that's why we can bring something else later for sort of how, because demand side management is very important, play a very key role in terms of how make the microgrid as a balance between sort of generation, renewable generation and the load. So it's very important. So this is another sort of typical example, which is called renewable generation profile. And then this is the profile. Basically, the what happened is we're looking. If you want to look at the home or building, so which actually I'm actually doing that. It's called home energy management system called HE management MS. Okay, so that is it's a kind of 3 people. And the weekdays, because we're talking weekday, week. So in March, so minutes by minutes. So we actually simulate. If you do home energy management system, you have to using the home load profile rather than aggregate in the microgrid. Aggregate means if the microgrid will be more than 100 house or more than that, or in the flat, it's a regional, then you have more. So the profile before the profile was aggregate, and then this is a more kind of individual. So if you do this home building, home sort of energy management system, then you have to using the home profile. So that's why I put that as well in terms of that. So this is just looking very spiky because people using the electricity whatever they wishes. So they just take it down, take it down. So when you look at this kind of a kettle, I put a kettle, maybe it's the same time cooking, you like electricity. So this is what we call peak, and then majority of that. So if you install PV, that this is a really question. And then we are not talking about that yet. So what would happen with PV and the EV? So that means electric vehicle. And the PV panel is more generation and very predictable. When you have sun, you have daylight, you have electricity. If you don't have. The EV possibly quite good, but they are on most of the case will be in charge during evening. During the day, they drive. So this is profile is absolutely not occur in the same times. Okay, so that is what if the customer happen the same power peak as simultaneously? So that is, and then the other one is economics. Very important because at the moment we don't have a kind of incentive economics in the guideline, so we don't changing our behavior. So in terms of operation aspect, they basically say we already mentioned in national grid they operate so different generation. They give a different price. As I mentioned earlier, the lower efficient generation, they normally have a low price. The reason is they can export their generator a lot more. So they can have, let's say, 90% or 80% of efficiency export. So they can take money. But in traditional conventional, it's a big one. They probably not that efficient. It's about 40, 50%. So that's why the price is high because another half capability they're not being fully used, but they have to. It is a cost. So that's why you have different generation has different cost. So now, how to dispatch that power flow, which control this two bus bar, is up to whatever the national grid or whoever utility operated. So that's why they have. But it's important for the utility. They have to thinking. You need maybe traditional, very expensive, in order to support security, and then lots of maybe distributed, very low cost, very efficient. But you can't just have a completely efficient, very cost because you fail the security as well. Okay, so that is a kind of situation. So again, the security supplies. If you don't, how you can increase security supplies if you have faults, then this is all gone. Then you have a blackout. Then what we do is we just simply adding kind of extra line for that. So in UK, we are very lucky because in all the transmission in national grid, we have a double line sort of transmission line. Then in distribution network, lots of also double line in kind of a high HV side. The other if the MV and the LV, they are kind of radio. Okay, so this is what the fault occur. So we construction, you invested, then how this is done today. Okay, you're just adding something. Then so a kind of a put a redundancy or what we call N-1 security or N-2 security. So that is how the traditional way to perceive that. Okay, so but obviously this is slide that just tell us, say, how about what we provide security today. So one slide to talk about America, New York, 2003. That was a long time ago. Then we have another one in London blackout. Okay, so we don't have much, but that is just illustrated. The security, you cannot guarantee 100% security, especially when the sort of renewable coming is uncontrollable intimacy. Then we have a lot more problem. So now we back at what are the previous slides. Just to have a little bit of concept, try to really clear between the what we call smart grid or what's the level, what do we need to consider. So for example, we need to consider economics, we need to consider security, and then that is two sort of aspect we illustrate. So now we back to this classic power system, basically to look a little bit understanding. So classically, we have a conventional generation, transmission, and then what we call distribution network. So in UK, we have 3 transmission, mainly is in national grid, UK. Then you have Scottish Power and Scottish Southern. So and then Northern Ireland. But we consider Scottish is one of kind of transmission line, and it's basically owned by Scottish Power. Then you have Northern Ireland as well. So it's about 3 sort of region. One is mainly Wales, England. One is in Scotland, and one is in Northern Ireland. Then in distribution, we have roughly 14 distribution company. So they own kind of this area. Then, as again, this is kind of a traditional large plant thermal at the moment. The main touching is about passive. So load is passive. So as I mentioned, load profile before is we have a non-restricted sort of load profile. The customer don't respond anything, but you cannot control them because they do whatever they like. So it's kind of uncontrollable, and then they are not respond to what because the price is flat. They don't respond, and although they have economic 7, but there are very few customers to actually use it because as I mentioned in hot water tank, I don't really like hot water. If you want to massive storage hot water, you need a lot, but you probably occupy one big room, or people can put a roof and so that is what we call. So now the power flow in distribution is one directional. So there's a power flow. Then we call passive network. But in transmission, as mentioned, they always has a kind of bi-directional because they needed to make sure that they buy cheap electricity and then transmit the power. So sometimes they buy from France or Europe, and sometimes they use in their own. So that's why, but in distribution, they always one direction called passive. Okay. So again, this is just talk about trilemma energy. So we're touching in previous slides about carbon emission. So this is what is the purpose. Then we worry about security because wind is not that intermediacy. They not give you kind of uncontrollable. Then we're looking economics. So how you dispatch more efficiently. Okay, so there's 2 things we already mentioned, but this is just emphasize a little bit of how these 3 things you need to consider when you develop a smart grid or maybe microgrid or maybe in the home sort of grid, if you like to say home energy management system. So that is a kind of a perspective. Now we look a little bit classical for today to current. So what changing the current is basically we install DG everywhere. Okay, so distributed generator, or maybe you say can be in renewable, can be traditional, and then with a very low carbon emission technology. But they actually installed everywhere. But one thing's not changing is demand is unresponsive. So what we call is now, because transmission always operate sort of dispatch, what we call active, always. But distribution from passive, one power flow, now become power flow 2 directional. So in terms of power system term is what we call active management system. So this is done by utility. So customer not involved. So that's why customers still not involved aspect. So in current situation, then we have already started to do that. But then some will say, okay, we have a bit of smart grid, but this is most part at the moment is a pilot sort of scheme. So it's kind of a smart grid. Okay, but there's no massive kind of we can claim we are now in the kind of a microgrid or smart grid region, but it's called active. Okay, so this is just a very quickly go to sort of wind technology, solar tidal wave technology. So then you can have a look at electric vehicle technology. Then you look at the low carbon technology. So low carbon that means you have a heat pump, okay, and then what we call smart appliance for freezer. So one of my interesting project for freezer is that you basically for example, most of food is like I say under -20 is okay. But if it's a price different, then I can push my freezer into -40, 50. Then if it's electricity high, I stop on my freezer. That it's naturally this kind of a temperature rise up to -20. Then I have to use the electricity again. So that means you can have a little bit of smart control. We call smart appliance, similar for dishwasher for the washing machine, because when the electricity price high, I'm not necessary to use it. When it's low, then it's just fire automatically. So you can, well, that's what we call low carbon technology. So now another look is, this is just quick slides, very, very quick, going to illustrate. So what we call the wing in feeder. So that means the wing is so much intermediacy, so in fluctuation, right? So you have a very high wing and a generation and a very low generation. Okay, so then you have what we call the capability to install, and then you have then most important, we're just looking how the wind will affect the system. Okay, maybe affect your system. Okay, so this is another slide. Basically, say this is traditional. So you have what we call no wind scenario. So you have a nuclear, coal, then gas. Gas is very efficient, but they are fire when we demand. Okay, then this is very stable, and this is kind of traditional. Then you have a wind coming. So when you put a wind, then this is much more. Then this will be probably exceed your capability. So how we respond that? Because you either put a reinforcement for your electricity network, and then, or you have to do something. So that is what we try to restrict. Okay, so what do we now, when we want to do something, so we obviously have to make sure that either you put an infrastructure, or you can do another way called smart grid way. Okay, that's what we're focused on. Okay, or the microgrid sort of. So that's what we are moved to. For current, you have generation, but then not respondable to the smart grid. So what is make the smart grid slightly different? So you have still climate changing, security, technology. Then what is important? You looking markets. So it means you need input markets. So it's different price. Okay. You need people involved. People, very important. Maybe some aging assets. Okay. To replace or maybe to utilize them. So this is kind of things. Okay. Then you're looking. So what it actually does is now what happens, you have the exactly same, but most important is active, responsive, and demand side technology. So that means the customer, as soon as the customer involved, then customer will change their behavior, demand. So what we call demand response or demand side management. So that is very important. How you achieve that is what we call IC-based, flexible, and control. So this is really focused on our topic today. Okay, but we just showed it because we have a little bit background to talk about that. So this is what we call current. So most important is you have your market, people. That is two sort of aspect. Make that changing from unresponsive demand fix to active response for and demand sort of technology. So this is what we're looking for. Then in order to achieve that, we need IC-based sort of class control. So this is a coming little bit of smart grid. So, or maybe you can say macro grid. What it means by that, there's lots of definition. So I just coming very simple, probably more easy to understand it. Smart grid is the power plus ICT. Now I put a question mark, maybe someone might have a debate, but this is my understanding. So this illustrated this slide. So from power side, we need active people involved. And from technology side, or you have a power side technology, you look active, whatever, demand side management. From enable side, enable achieve that, you need IC-based flexible control. Okay, so that's why we call power plus IC. So power means you need demand side management technology that people can change their behavior. They can install, invest their PV and renewable and storage. Okay, and then but from the technology enable side is IC. So I define this as a kind of energy operated design planning and optimizing according to control-based diagram rather than asset-based. Okay, so this is then it is integrate of kilowatts or megawatts. Sorry, what the question? Some question. Is there anyone? Is it okay? It's okay, yeah? Okay. Okay, I just see some message. Okay. And to make electricity network can costly. Sorry?
We have a separate queue which non-conventional source is more cost effective and efficient for microgrid or distributed generation.
So can we leave this question later? Okay, I just try to go through.
We will take the questions in later.
Yeah, because I want to finish this in case someone stops, and we can always discuss later. Okay, so basically integration kilowatts and kilobits and megabits. Okay, that's what we're talking about. So you can debate that, but anyway, we will talk. So that electricity can be cost-effective, integrate low carbon technology, as well as action all of user to connect to it. So that's very important, right? So if a user not responding, then we still call active, not smart grid. Because if it's the customer not involved or participate, then that is a sort of challenge. Then utility already doing it, right? Already put active everything like a management or distribution management already doing it. Okay, so that is so now the question is, we have a little bit of sort of control center with everything linked together with smart city, smart home, whatever. Then how they do this? So this is a really question. How do that? Okay. So this is what we call smart grid need to be flexible. Okay, so that's another thing. Flexible describes system able to cope with events that might occur, imbalance between supply and demand at a different time frame while maintaining the system reliability in a cost-effective manner. Flexible always being presented the power system, but it operates require that increase future with more renewable, like CC. This is the kind of a gas control technology, and a nuclear, which is more kind of a low carbon, and then more flexible will be able to for network in order to maximum asset utilize and develop non-asset solution provider capability. So that is, but obviously there's lots of other related to flexible. So we have limited. Now this is a quite interesting one. So the we call duck curve. What it means by duck curve, basically this is related to California. So before we have a load profile, right? So the kind of a load profile, very traditional way of load profile, let's say this one. Okay, so then what happens, the duck curve is the PV plus load. So that means if you have a lot of PV, then demand is a drop. If let's say this is for the utility concern. So if let's say you have lots of home using, so their network demand is a drop. So it is a great demand drop. But because what happened is the micro smart grid, the people has their own generation. We call zero net. Then what happened to distribution network? Because they have a capability. So in this building, this time in during day, suddenly their electricity network is redundant. It is no longer whether they need still investment. So that's the question for utility. But obviously, very good news for home. So, but it's kind of need to consider as well. Okay. Then what happens is this is called home and flexible demand response. So I give it very quick because the purpose for this is a role, but I needed to look a little bit on sort of the technology, which is by my colleague. They actually are using their colleague sort of a device. It's called, so what we call the appliance classification. You have a containable appliance and is a deferrable appliance. So that means you looking different the technology, then mainly is for demand response. So that means if you can control this kind of appliance, then you can modify customer load profile. Okay, so what do we call in smart grid? They need a demand because we can install whatever we have a PV. But if we control the customer. We can using different technology. Actually, I don't want to go through it, but I'll give you slides. You can look at it in the question. So the purpose of doing that is you look at the classification of different load appliance, then you modify customer behavior. So this is back to this slide. So you can changing this demand depends on whether this wind blow or not blow. Okay, so that is one thing. So that is what we call. Then you have another perspective is called price vulnerability and spike because of the variability. So what happens? This is a really challenge for the people with planning. So because of what happens that we mentioned the price, if you have a planned inside of the price is relatively manageable. Then if you have unbalance, basically in terms of this, you can start to have an unbalance. So you expected that. So you balance that very well. Then you say, okay, I control every price below that during this. Sort of you have a small reduction in supply, maybe cause large change of a peak. So if you can have planned it, then certainly if you have not enough supply, then you can make a price very high. So normally, because you almost, let's say, you have a contract, then certainly you want to borrow something without contract, so they can borrow very high price. Okay, so that is something. So then what happens is if you planned it, expect it, so everything's okay normally. But now you suddenly say, okay, actually there's no enough wind or maybe predict something not quite right, then you suddenly have the actual supplies drop significantly. So what happens is before you thinking, oh, this is okay, I have a full little bit price up to that point, it's okay. But after that point, I'm have to do something, or maybe then now it suddenly come to this point. So everything in allocate this area is a so high price, but then they will reach this kind of minimum. You no longer can afford it. This is green. So what you could do is called demand response. You can just control this demand appliance to make this curve falling back to this point. Okay, so it means you can actually cut the load and then make sure that they have reduce the load demand. So that's why smart grid or microgrid demand side management is play very key role. Okay, so this is kind of then you also flexible active management. So this is a active management. So when we're using tap changer, whatever, then you can coordinate with different generations. So I'm not going to talk about that much. Then they have a typical scenario you can study. So different things. So it depends on you looking sort of active management one scenario. Active management means you looking tap changing, optimal fixed tap, DG active containment, stack-on, and then you have a no load tap. So basically, so then you have what we call with optimal flex tap. So there's a different technology, and then you can study and then make the best strategy for the network. So that is another flexible. So what we're talking here is more kind of flexible the network operation and planning. So you put the open point, then you can install demand side response technology that you can make that as. So this is called C2C. So basically increase the capability for the utility to do that. Okay. So what I'm trying to do is basically this is how ICT can help. Also, we'll come a little bit touching this main topic. So what we said here is basic the power system management. So this is applied everywhere. So we can talk about distribution and a company or something. So we mainly say different ad hoc topology of power system existing today. Okay, if you go different company, they probably will do different things with different kind of communication architecture or whatever. Then, but below the most common technology is, so this is what we call most common kind of concept is you have EMS system. If you go to distribution called distribution management system, If you call microgrid, maybe you call microgrid. If you go home, you call home management system. And if you go to building, you call. So this can apply everywhere. Okay, so you have a control center. Then you can have a wide area network, basically to look at the generation, distribution, substation, and the load. Okay, so that is what we call wide area network. Then what we call in substation is a little bit more complicated because the generation, you just go each generator. In substation, because they are what we call intelligent node in the network. So they have different things. So you have a substation, the monitoring and the control system. Then you have a local area. Then you call ID, means intelligent device, so measurement. Then you have relay, probability classified, because this is a kind of a relay. We talk about traditional mechanical relay. This is called electronic relay. So you can arguably in the future everything will be merging together. Then RTU, so remote terminal unit, so basically to gather information from different aspects. Then you have CTVT. So, but obviously I leave something else for imagination, so you can put whatever, because they have a PMU, okay, metering, etc. So this is not just limited to that, but what I can see, this is very common, but you have a pioneer. So that is kind of architecture which we're looking for, okay? So you have an object division, communication network, and a SCADA system. So in here, you have a SCADA system. Now, one of the requirement for whatever, so there's a little bit of, so you have a protection and then SCADA or market price or control limit or online temperature changer. So this is what we call operational. And this is what we call. So if you like, our smart grid or microgrid will allocate in this green area. Okay, so this curve is about time required. Because when you're using communication, you need to understand what is latency. So you can't just say I'm using whatever I like, but especially in the past technology, maybe 5G give you a little bit more faster, but obviously what the cost associated with is obviously. But then in this topic we're talking about, we still don't have a 5G yet. And then you have also the communication cost. When you're using communication cost, it depends on you are locally or you are in wide area. Okay, so if you look locally, home, probably very little cost. So we have less concern about communication. You just put a wire in your home, then that's less concern. So you have massive bandwidth. But if you are the microgrid, maybe slightly better, but you still need to put the infrastructure. If you are one called Manchester area, which is bigger, then that is a little bit cost. Then you have a national grid getting more and more. So that is a cost associated with economics. Okay, so protection is very local, but they are time required, very, very required. So that means they are relative okay because they're local, although their time latency is microseconds, but it's more alright. That if you look at in the past, what happened is SCADA system, they are very wide area. Okay, then what happened is they are the time requirement because they only looking dispatch, monitoring, they don't do protection. Protection need quicker. So they are in category in this area. So that means if you look at the cost, it's okay because wide area high, but because of the time latency required in their area. But what we do is here is in the future we call smart grid or microgrid. In this kind of location, you need to look in kind of a generator control. Okay, so on the frequency scheduling, load scheduling, which we'll talk about, you need to schedule the customer load. Obviously, you might need islanding and some kind of fax device control because of power electronics things. So this is really is kind of category looking for in here. So how much we can need to communication implement each of this function and affordability for not core business. So that's very important because do you remember we are in power? We are looking at power, but smart grid is about power plus ICT. So we are not very good at the communication anyway. And we are apply communication. We're not needed to develop a communication, but we need to understand how the best way to apply. So that's what is this talk about. Now, just a quick touching communication. So communication and IT technology. So what we needed to clarify communication. So line medium, sort of a microwave, okay, satellite, mobile phone, optical fiber, whatever. Okay, so you can do that. Then people now sometimes talk about power line at home. So maybe it's wireless now. It's more wireless. So we should be using wireless. But that is what we call wiring link or network link technology. Then looking ICT in communication, so sometimes we confuse. So what means information ICT communication technology? So we don't really care about the wiring. We're looking at software. So this is a kind of a point-to-point sort of network. So it means you're looking the point-to-point of telephone or something, go to three switches, and then you have central, then you have switches. So then you have what we call token ring. Okay, so this means you also have that. Then we talk about LAN. Then we talk about wide area. Then at the time, the difference is called network P2P, the network LAN and the WAN technology. Okay, this is P2P. So basically, mobile phone, telephone, point to point. They're similar to ring, and also P2P. Then you're looking at LAN and the wide area. This is a service, so we call web browser. So they put some platform can to sort of communicate seamlessly between device, email, etc. They call service. Then we also have a 1G, 2G, 5G, 4G is also categorized like kind of service, maybe 5G. So what we said is the fundamentally is this is service want to connect all this link together. Okay, so for example 5G. They put a lot of switching technology that make that antenna. Obviously, it's mobile, okay, but they are using clever antenna. Basically to not only share the space, share the point to point, but with movable kind of a point. So almost you have a point to point, then you move. When electric vehicle, you point, just like a microwave. Kind of because of the space, then the microwave can be changing according to sort of your movement. So they were using this kind of, but the service, how they develop the software with that. So this is what we call technology. Okay, so we understand a little bit. So we can use it all. Okay, so that is kind of something we can do that. Okay, so now, oh, I cannot do more move now. What happened? I cannot move that now.
So if you'll see in the bottom side of the left side bottom of the slide, you'll find the forward.
Okay, no, it's okay there. Okay, you gave me this pen. I'm not very familiar with that. Okay, I'm normally using Zoom anyway. So, okay, so that is kind of a technology. So now, another thing is very important, very issue, because I'm more kind of a question, give you the question, because communication technology is there. But what I'm thinking is, I've been looking for what the difference between power engineer thinking and the communication engineer thinking. So I keep pose this kind of, so is it this the same wavelength of thinking? So this is what we call ICT engineer. This is a power engineer, okay? So a little bit, so I say, well, there's a gap. So we talk about same reliability. So usually people will, power system say, oh, I want the reliability 0.999. Okay, that's what we're looking for when we talk about power systems. Oh, we need a reliability. then the communication say, oh, this is very easy to achieve. But our experience for communication network is actually they cannot achieve that. So there's something, look, we're talking different things. Okay, so that's why I put this kind of. So now the engineering say, of course we can do it, because if you look at the data for internet banking, do you think we don't guarantee you 0% in the line? So if we have a billing, if we don't guarantee, we lost a lot of money. So we can give you 12.9 or maybe even more 9, because we almost, let's say, communicate to bank transfer kind of money, they almost very little losses. Otherwise, everybody can transfer, maybe say couple £1,000, maybe one digit is gone, right? So you are not happy, right? So that's why you can do it. But our experience basically say, oh, no, you cannot do this. It's because we don't experience you do that, okay? Because then if you say, you actually, we always experience IT, sometimes the communication, like our internet will be disrupted. Then we simply lost it because it's a slow process. So that's what we experience, okay? So obviously something with a gap. We're talking about the same thing, right? Now, then we say, okay, so what is the main difference is in communication, ICT people, we say main objective is advanced technology to increase the service, then retain customer. So that's why we need 1G, 2G, 4G, but now we have 5G. And we need a fancy phone, mobile phone, from very little phone, but we have a more smart, and do lots of function. Now we do the camera rather than phone. So this is a more kind of technology, try to attract people. But application is more voice, data, and computer internet. Okay? But in power, our main objective is deliver power reliably and efficiently. We don't really care, but this is my main issue. Security, something. But our application will be fast response for protection control, and microgrid might need a self-healing. Okay? That is needed fast. Then slow, relatively slow response, which is a planning, operation, and a telecontrol voice data. So this is category lay on very well in application. But what we do is we experience when we need it or the line, but the communication is their not core business. So they don't develop this for your specific use. Okay? The banking will be category into computer internet. Okay? You can be slow, but when you transfer the technology, say, if I'm transferred to you, then if something wrong, I say, I receive data, not make sense. Then interrupt for a minute later, I say, I didn't receive anything. Then you can ask to retransmit again. So that's why they are checking, error checking everything. If they find something not right, they ask to repeat. So this latency is not issue. Okay, so that's why they can guarantee you transfer. Okay, so there's more. But in our case, like a microgrid, we are in following that category, but remaining is okay, but ICT people don't understand it. And you also tell them, you say, if I don't want to latency that, I don't have money to pay for it because it's not my core business. So that's why we have different things, okay? So just to understand a little bit around that. So that's why our challenge for the power is we need a kind of self-healing, we need to control customer demand very quickly. Let's just say fast resolve. You need to take the power balance within, I think I have some figure. So within maybe a minute or maybe less than that. But it's sort of very needed fast. And also you control generation curtailment or something. So you need it very fast. But this category is not lying in ICT, most people in mind. Okay. But this, although they can achieve it, no problem. Okay. But sometimes it's not their interesting to do that. For example, I'll give you an example. Say we have a, let's just say token ring in national grid that they can guarantee you sort of point to point. Okay. So there's a substation, another substation called differential. Now they have a problem is because this technology is there, it's okay. But when they try to develop a service, like they want to switch into package switching. So packet switching, they still can guarantee your path is good, but then you want to introduce the protection of the device. So if let's say you guarantee this latency to that latency is exactly same as a return path, but now this line is a fault. Okay, but in order to maintain service, they don't want to interrupt. They need to switch automatically back to different ring. Okay, so it means if you deliver from this line, then you switch automatically from this other. So they go through many nodes. So latency for this will be different from line latency. Now this is very good for switching, but not very good for protection. So that's why we're using GPS to try to resolve this problem rather than ping pong measurements. So that's what we have at challenge as a little bit of challenge on that. Okay, I think I know how to do that. Okay, I know how to do that now. Okay, so that is something which we are not, but we don't tell them. Okay, we didn't tell them what we do. So we needed this, but the engineering, they say, oh, we want more, because we want more service. We don't want to interrupt what the people communicate. So that's why they're using different technology to do that. So that's why we have a gap. We talk different things, okay? Then, and also are looking different business priority. Say, if it's a communication operator, they're using voice and then using data. The market is massive and more money, okay? So in our operator, we have a protection of equipment, voice and data, and the power communication is less money. So because power is a relatively small kind of. Then your latency, look at voice, less than 500 million seconds, because we know the satellite. If we have a satellite, we have a 1 go R, so roughly, but when we voice, we can actually afford to understand it. But after that, then you will see some latency, maybe lots of delay, maybe not hearable. The quality of voice is very bad. Then the data happen with seconds. Okay, and then the latency for that is power is you need microseconds. That's similar to with telecontrol and data SCADA with that. Then the development priority is the connected customer, more assets, copper, wire, fiber, rich customer. Okay, multiple service. For example, in our home, we have a cable, we have a optical fiber, lots of things. In almost you want it, you can do it. But they invest it, put this anyway. Doesn't matter. You all ask. The multiple service attract more customer and the quality of service retain customer. So that's why at previous are touching, we only the switching path, they want to quality service. But we don't. Our priority is reliability, efficiency, availability, and reduce outage. So nothing related to what is communication. So that means if you look at the business priority, they are very different. Okay, so how they bridge a gap? So that's another thing, is the core business. So let's just say you have a core business voice data, short life technology, it's very important, and a 20th century technology, and a BT 20th century network. Okay, and then it's the BT century advanced mobile service from 1G to 2G, now as 5G on the way. So they are super confident people who can deliver 21st century ICT for any smart application. So that is when we do that. So they have lots of people. If you go to secret conference, lots of people already start to enter kind of a smart grid market, sort of try to provide a sort of communication technology. But in power, we have a very conservative thinking for a reason. So core business develop power and keep lights on. Main objective is efficiency, reliability, and availability. The user reliability and the security, communication, cloud, internet, but unsure, because that's why we have a security, the internet security issue. So I'm studying now is security. Too complicated to understand a new technology or ask any needs, impact, short life. This is very important. Life cycle technology on a long life power asset. So it means they are very short life. So mobile phone, how many years you're changing? Maybe computer, how many years you're changing? So that is something. It's like And then in power, they say, oh, this is not my core business anyway. Okay, so favor building private network. So they lot of people calculate, say, oh, we have our private, but it's too kind of expensive. So all in one through limited super highway communication, which we're talking about cloud, without the proper data management, will make things worse and better. Now get a bit of water. Sorry, a bit dry. Okay, yeah. So now okay. I'm assuming. So that is a just look at this issue because of what we call the challenge issue, which I'm talking about. But I'm not going to talk about too much about that. But I just say how we're going to do it. So that's kind of a remark. So ad hoc communication technology everywhere. Moment we have a wide area. We have what we call ITU or distribution automation. We have a primary feed protection with pilot line with dedicated sort of communication. Then we have line area with substation automation or digital substation. We have a SCADA system in control center with dedicated link. We have utility office use. So you look at this, all this technology is called enterprise office use, EMS, DMS system. So if you microgrid, maybe you say microgrid management system, home management system, and protection control, substation, and distribution machine. So if you look at all this technology there, then what we said here is if we want to have ICT, so we need to understand all this technology. We don't develop it because there's no point for us to develop. We just use it. So we are in power. Our main focus is in power. How make smart grid or microgrid. And we look at the different technology available, then say which technology is probably is the most suitable for us. So when you develop what we call communication for microgrid, smart grid, then in order to look, then one thing is I just proposed because actually we done that anyway. So define a rule for simplicity. So we need to understanding. So who doing what, and then ideally we should have a standard, regulated standard or interoperable. Because interoperability is very important because if you invest something today, then next day is gone because 2 years time technology is moving. Then your system no longer be able to using new device into it, then nobody will invest it. They are looking for 20 years, 30 years, or maybe same life ICT as a power. So we are now as stuck. So that's why regulated standard interoperability is important. Okay, so I will give you some example. So what do we do here? Then utility solution or smart grid solution or something, you need a standard for energy management architecture. So when you design, you say, oh, this architecture is good, so I want to do this. Then you need to look at the equipment provider, ideally from multiple vendor. So one vendor is gone in sort of an economic crisis, then still come up other vendor is there available to support, to do service. Okay, so we don't rely on one vendor. If we rely on vendor, we have lots of problems, security problem or monopoly problem, lots of problems. So that's why we have to go to vendor. Then you have ICT, IT integrator based on defined architecture. Okay, so this is what we call, first of all, you need a standard. The second one, utility has its own architecture. So when you design microgrid, you need to say, this is what we design. So that's why we play a role for utility because we are expert on power, okay? And then vendor solution, we're looking for very different price. Then utility solution means integration because probably people integrator is better because they are better IT people. Okay, but then our design say this has to be do this way. So then also utility solution. So utility solution for IT and the utility solution for power. So that's why they reach the gap. So that's what I think is the framework or proposed, so which we do. So now I'll give you example. So it's not me, it's actually lots of people doing that. Okay. So first of all, we all familiar with GSM, okay, for example, but obviously they move on 5G. So GSM actually is open defined by European telecom standards. So that means we need a standard. So first of all, you need standards. Okay. Then after the standard, then the people communication, they design their own architecture called mobile station and a base station and a network switch or something. Okay, so they do that standard. Okay, so this core is a standard is utility. Okay, then they go to your communication kind of network because they know is called packaging switching, different network. So this is called IDS. I said it's sort of internet, then post. So there's a different interface which are basically related to your the core sort of a computing network or something. But this is in UK we have a BT network. So this is designed for network, but it's not for mobile. But when you telephone mobile, then they go to national kind of network, then to the others. So this is wireless. But in terms of this module is a standard architecture. Okay, so that is another. So they can actually expand that. Then in here you're using cellular kind of structure into it. So that's why they hopefully they can cover everything. So you look at the mobile phone technology. So they have the standard. Now I'm not sure. Okay. So actually I'm missing something, but probably we're adding something in. So it's kind of a BT century network. So which is a very good example in here. It's actually BT. They design their own architecture. Then they have different multiple vendor. They have Ellison sort of communication to have one integrator. So I missed that, but I will add it in. But it's something, but actually they spend a lot of pounds. Actually now they become the biggest sort of internet communication provider. So it's too big, they can separate them. But they have a standard, they have their own architecture, and so on. So that is what we call from communication perspective. They do a similar way. They have based on this framework, even in communication network, they will do have a regulator, if you like, is an open system. Try to choose open system first. So open, anything technology. Then you design your architecture for your, what we call the microgrid application or home level. Then you look at the provider which can meet that standard. Then you have integrator to help. So that is one of GSM system, which is this. Then also we have a BT network, next century, that's called 21st century network. They also do this similar project. Okay. Now, because whatever I do, I will touch a little bit of my work related to, but obviously my work is more kind of a digital substation. So we actually design for UK network called architecture of substation secondary system. They were using AS3. So that means you have a 3S in the A. So architecture of set. So that is what we design. So we have designed this kind of since 2001, 2008. So Manchester has developed flexible digital substation architecture for national grid project. So that's what. But this is exactly based on what we proposed. So we say digital station vendor interoperability bay for future substation. This is a little bit off, but I would say because we're talking about communication technology. So our role is not about communication technology. It's about architecture. It's about what is open system architecture, what the vendor divide and how we integrate. So that means I give you one example. This is my example, but with different perspective. So we look at the communication. Okay, so we don't care what is the communication. We just choose it. So we look in the architecture. So vendor operability for bay for future substation extension. That's the one of our requirement. The standard bay reuse, prove design, and reduce risk and deliver time. Okay, we need a rich gap. It means communication technology is a relatively short sort of life cycle. Power is a relatively long life cycle, how we meet. So that's why we need for this kind of following this framework. Then digital process bus, obviously plug and play would be great because install, replace, reduce the system access. So it means if you design architecture, you should have the standard can plug in, play very nicely. So when we use USB, we also plug and play. So that means so that's wonderful. But you with the software, the using device, you can plug and play. So that means it's make the design is more long term rather than short term. Okay, so that is then you have a vendor interoperability, then challenge for effective, then you have obsolete because basically to have a vendor interoperability and the interchangeability to efficiently manage obsolete and cut the post-delivery service sort of cost. So what it means by that, as I mentioned earlier, say some device, some company might just have an operator, then suddenly have a financial crisis, they close down. So you cannot buy similar, or even you buy sort of that in 5 years time, they have a new device. It's not, we all experience of kind of operating system, you always update. So that is something which we have to consider. Then you have standard, so I make sure that you can do that. So our flexible digital architecture is exactly the same as that before, but slightly altered. So we have a standard station bus, okay, and the management buses. So this is standard. So vendor independent solution. Then the bay bus, we have a vendor-based solution. Okay, so basically utility design. So in this case, I design for national grid for this blue or red and the blue and the green, but we do this different because in order to have that reliability, we have used double bus. Okay, then you have a station bus, measurement bus. I will talk about that later. Then we select a vendor solution, which basically they using the vendor. So all this is based on the standard IC 650. So that means it's a standard. So we have a standard framework. We design our own architecture. Okay, then vendor solution coming, and then vendor solution coming. So they have what we call merging unit. So digital merging unit, basically analog to digital, analog to digital. Then you have a digital to control breaker. That's similar for protection device, measurement, etc. So this is the vendor solution. What our role is design architecture for that. Okay, then this is based on the standard as available. So I'll go very quickly, then I'll try to draw some kind of, I think it's a time issue. So now actually a multiple vendor, which we have actually developed, it's called virtual site acceptance test project. So it's kind of based on the, so we basically to develop that this is the architecture we'll talk about. So first of all, we have station bus. Okay, so this is architecture. Then you have a process bus too. Then it's a base solution. Then you have a measurement bus. So that is something. Then you can connect this. Then you can take the bay. So what happens is if the vendor can design their own bay based on this architecture, you can replace that bay very easily. So that's kind of expanded very easily. And also inside you can using a merging unit, a digital. Then you can use in protection called non-relay bay. So we have actually GE bay, non-relay bay, ABB bay. So kind of a different vendor. They deliver their bay. So we can replace any bay which wishes. So that means you not rely on one particular. So in our lab, we basically to using RTDS to simulate the power sort of a condition. Then we use amplify, then do that. So the concept of doing that. So when we finish this, and I think it's very, very easy because the vendor only develop their own bay. So they actually deliver their bay to us in our lab. Then we just play a little bit integration very quickly, then connect them, and then we can remove them and put another very, very easily. So it's kind of a modular plug-in in the play. So actually, this is very similar to kind of a cloud concept at the moment. So it means you actually doing docking sort of way. So you develop what we call dock system. Then you have a container coming, just plug in the play. So that is very, very similar. So we are doing almost the same. As I mentioned earlier, the concept is not just we created. The concept is the IT people already doing it because they need a quick sort of, but they don't change their architecture. GSM don't change, but they can change their vendor or mobile or something. This is a similar kind of things. Okay. So basically, I think what happened is all this is okay, but I just gave you kind of as a slide to talk about. So now the one thing is because what happened is all these architecture in place, especially when we do some LAN, as we know, if you want to faster sort of control, so we rely on WAN. Okay, wide area, they have latency. But microgrid maybe is less, it will be better because it's really regional. So that way you're talking about a slightly different thing. But because of sometimes the communication might not meet the latency requirement. Okay, 5G is not there yet, but 5G technology changing revolutionarily, but it will be good. But then what are the costs associated with that? So what we said here is the one thing is very clear for me is that we need a collaborative intelligent control. What does that mean by that? Is, for example, if you have what we call decentralized control, which means the power relationship can respond some events automatically. Okay, so that means they have it's called local intelligence to do that. Okay, but some events happen, oh, I have a shorter. So you detect something, then you should respond very quick. Because if you're waiting for centralized instruction, it might be too late. So that is something. But then why we need a coordinated control means centralized will give you some picture first. So almost let's say, give you the status of a previous status of the operation condition. So that means if you have a previous of the condition, then you likely respond very quickly. If you don't know the previous condition, you don't know where you go start. So that's why centralized will play a role to divide many scenario, so like an operation condition in different region. So as soon as you with the region, then whatever happen in that region, sort of a decentralized control unit can respond very quickly. But if it's not categorized in my region, but that events may be not associated with me. So that's what I think is. Now this slide is my suggestion, but I would do because I'm not going to say how you use it. It's just bring the concept, and then this is the purpose of that. Is the green concept. Then you can start to thinking of this concept to see how they do it. So if you microgrid, for example, if some status, because in that region, then that device has to respond very quickly. But because what happens is they don't, when you do local, they have a very small eye. So focus on local. They don't know what is the bigger picture. So that's why centralized coordination play key role on that. So they know the whole picture. So when you look at the status changing from one state to another state to another state, so that is relatively slow. So if you want to isolate that status, then you have to operate very quickly. So that's why we need what we call operative intelligent control with a centralized kind of a coordination with decentralized intelligent control. So that's what we call proposed architecture for that purpose. That is slightly different from the architecture is related to how you dealing with the latency fast. So that means we raised the question before was in our microgrid control, we are into the category which might need a very fast communication, but then communication might not be able to. Either they're too expensive, which might be 5G, or maybe they're not available. Okay, or they if it's not expensive, they may be the time latency. So that is what we call proposed architecture for that. Right? Okay. So then I just touching a couple of work which actually involve this kind of a class project related to the smart grid, or it's called load response. So this is what we saw. My price paper actually is based on that class project. Okay. So we have what we call the customer load active system management service. Okay. When we touching the before was talk about the load demand response. Okay. So class project S is a kind of active load response. The difference is at the moment load response, you need to have a contract with the people because the customer involved. They say, oh, you control my load, and then I don't like it, so you need a contract. So in order to do this, it's very complex, and they're very complex because it's just endless of discussion. So what this way we do is we come a clever solution. So we know the system has a margin to play. Okay, so we also know that when this kind of generation is high, then you either shut down generation. Oh, sorry, when generation is low, then demand is high. You either shut down the generation to increase generation, put more generation, okay, to demand, or in our case, we just say, okay, we managing the load called reduction, demand reduction. So we only reduce a little bit by each customer. So if let's say 1.2 million customer, so imagine one customer maybe reduce a little bit, let's say 100 watts. So you accumulate 1 million, that will be quite significant. And then at the same time, when we reduce, then customer will not notice it because we just reduce their little bit voltage. They don't actually even notice reduce because we have the voltage region margin to play. Okay, so that means as long as it's within 10% or 1 second, it's a kind of fluctuation. There is no issue for the customer. So that's why we have this kind of proposed clever. So basically, to changing voltage, to explore, to unlock the network capability, then when we change a little bit, the customer don't notice, then we actually save money for them. Okay, because if let's say in UK we have 240 volts to become 220 volts, what does it make difference? It's the same thing. Okay, so but it depends on the power load type because some load type is a power constant. Obviously, they don't give you much. Even you low voltage, it's using same power, but majority of the power probably is voltage independent, dependent. So that means you need. So that's why we play. Then we play some optimization with this one. Then change a little bit of type changer. Then we can actually reduce load. So we respond. So actually, we call ancillary service from the distribution to national grid. So this is very successful because this ancillary service for reactive power, active power to national grid is being accepted, attended. So they can provide sort of a 550 megawatts in kind of regional northwest in here at the time within as I said, it was about 30 couple of by 15 minutes in a period. So that means you can respond very easily. Just simple control called load demand reduction response. Okay, so this is what I call. So we have involved this project. So luckily, it was accepted. So the idea coming from that. Okay, so I don't want to talk about too much. Is because basically it's a VAR support. This is related to sort of okay, you have a kind of a VAR support. So that is using type changer to do that. Then you have another new concept is called paradigm, which is related to, but at the moment we have TSO called transmission system operator, distributed network operator. But now what happens is when you do something in this area, and then you do something in this area, then you need what we call DSO. So it means distribution operators become no longer passive. They are more acting as a kind of a distribution system, because when you have different power flow and then you dispatch this, dispatch that, then become more behavior like a distribution system operator. So this is called the nowadays it's very clear the transmission line network, and then in the future. Okay. Yeah. Okay. So what is this is really beyond the smart grid is what with the city. So we are talking about city, or you talk about microgrid, and in this particular project. But the concept wise, I think very similar. Okay. So we're talking about the smart city, smart grid, microgrid, and then the home. Okay, so this is just a quick. So what this slide basically say power system of smart grid require integrated of system power with transmission. Okay, so I'm going to very quickly on that. So integrated system for smart city. Then this is just some other things which I'm not going to talk about. So key remark, I'll just go quickly. So key challenge for rise of the future kind of city or regulatory framework, particularly in Europe, and the business case. The home building are likely to become smart, independent, and how the city will evolve. It's not all about future, it's about the citizens. So what it means by citizenship is because customer has to be kind of involved. Okay, so I stop here. So now I'm taking a question. Okay. So I will read. Okay, yeah. I try to see if I can.
Dr. Lee.
Yeah, stop. Yeah, okay. Yeah, sorry. It's okay. Yeah, I'm sorry about the. I'm hoping that's okay. Yeah.
Yeah, it's okay now. Dr. Subo, can you hear me?
Yeah.
Yes.
Dr. Subo.
Yes.
Yeah, please.
You.
Okay.
Please,
Yeah.
Okay. Thank you, Professor Haiyu. You have beautifully explained the important features that is smart grid and the role of ICT in improving the standards of smart grid. I have few questions. I have noted down the questions from the participants. First question is what type of load we can use for a flexible DR?
Okay. The load, basically, I think a load is a fix. So now at the moment is what we call, it depends on what are you looking for. If you're looking the smart home, or if let's say looking the substation at the moment, so you're looking smart street, let's say smart street. So it means you have one substation connect many household. It's called domestic type of load. Okay, so you look at the aggregate of that load. So that means they are looking very much a profile, look like in the morning, they have a little bit of peak. Then during the day, because they go to work, then in the evening, they peak. Okay, so that's is a kind of a typical domestic load. And also you might look at the industrial type of load. Okay, so during the day, they have a lot more. Okay, so in UK, we have what we call CREST model. You actually can go to internet search. It's called CREST, C-R-E-S-T. That is developed by Rothberg University. It's a public available. You can using their simulation to do. It's called class 8 type of load. So class A1, class 2, then class 3, 4. So basically class 1, class 2 is domestic. Okay, so in my sort of slides, I already talk about class 1 is unrestricted domestic load. Then class 2 is the economic 7. Then class 3, 4, 5, all commercial type of load. Now, commercial type of load, why they divide a lot more is because class 3, they're using unrestricted. So that means that the commercial can use it whatever they like. Then class 3, 4 is very similar. The class 3 is unrestricted. The class 4 is economic 7 for commercial. Then the class 5, 6 is related to, they say, the restricted sort of 50%. So that means that they're not allowed to use what they like, depends on the network. Then you have another type. So it's the percentage. So you can go to CREST model to look at it. It's a very, very interesting one. Then you can look at it, see how they do it. Now, that is what we call traditional load. But now in the future, we have slightly different. So that's what we study. So we call, in UK, we call heat pump or heating system. So if you want to translate your home heating into electricity use, that's a massive difference. And also you have a heat pump type load. So this is all new. So now we are actually carrying out a study called load profile. Load profile is important in order to make management. For example, I have one project related to called installed storage. Okay, so you have a generation with load profile. So normally you have generation, if you have a net zero, you want to balance. The problem is that they are not the generate at the same time and not using at the same time. So you can using storage before we using grid to feed it in to balance that. But then you look at the storage, then the storage decide the size of storage is an issue because sometimes they have overlap. During overlap, you don't need storage. Okay, so the storage is only using for not overlap. So that's why the load profile is so critical in order to do the study.
Yes, sir. The next question is how price volatility scheme works while.
Dr. Shubho.
I am asking the last question.
No,
yes?
Dr. Shubho.
I can't hear much. Yeah.
Dr. Shubho, are you hearing me?
Hi.
I can hear you.
Yeah.
Okay.
Dr. Shubho, it will be very appreciated if our participant directly asks some question with Professor Lee.
Okay. Okay.
So
I am
Professor Lee.
Okay. I like to give the permission, and with the permission of our host as well as we like to give the opportunity to the participants. Please ask the questions directly to the speaker.
Okay.
Yes, very
good. They can raise their hand.
Yeah. Okay. Can I see? No. Sometimes it will be type. I can't see this any message. Okay. Let's look at chat. Okay. I can see the chat now. Okay.
Yeah,
sorry about that. I didn't know. I used to using Z. Okay. So let me to look at the chart because I'm sorry I didn't look at this chart. So let's look at a few questions about it. Okay. So the question: how price vulnerability scheme work when the recover from? Okay, I kind of, to be honest, I don't really can answer this question because I'm not in kind of economic sort of background. Now, I'm not really sure about that. So what I think is, because for me, I just look at my perspective because for me, it's like the demand and response. Because when we look at this technology in smart grid, then obviously we cannot control generation because generation is wind, is renewable, it has to be there, it's not there. So that is we cannot, but we can control in our perspective is the the customer behavior, how they participate involved. Now, at the moment, the price is fixed. Okay, so now this is the question is actually out of my kind of knowledge. But blackout is even worse because I don't know how this framework. But I would say because in from the smart grid perspective, what is the best way to do is we need a different price. So that means the customer can respond, so they can invest. But in terms of this question, sorry about I can't answer directly because there's another kind of research stream for economics, how they respond that. Okay, yeah. So let's put this second another question. If you do, I'm not sure this is. Okay, this is already okay. I think already answered. If you can put a question, it will be easier because there's a.
Dr. Subbo.
Can you write the question? Just put a question.
Dr. Subbo.
Yeah.
Dr. Subbo, can you hear me?
Okay.
Dr. Subbo.
It was a very good session today, and you have covered many topics and many questions. Some of the questions you have answered. So I like to give. So thank you, Professor Lee. I like to request Dr. Rajiv. He will give the vote of thanks to Professor Lee.
Okay.
Thank you.
Thank you.
Okay.
Thank you very much.
Thank you very much, Dr. Lee, Professor
Okay.
Lee, for your extraordinary session on smart grid and role of ICT. You have elaborated generation and load profile in a very beautiful way and in a simple words. You have shown new technology of smart grid like ICT based control and their role in the smart grid. You have also explained the flexible demand and energy management in this. I hope all the participants got the new way understanding the smart grid related technologies. And however, there is some confusion arise between the time slot of India and UK. You just come to know it's according to the Indian time. Within 2 and 3 minutes, you have joined the meeting. It's showing personality so that the work those you are to say about dear Dr. Lee has not only achieved all the things by default, by he has devoted his energy and hard work to achieve the things. And I have when I was working with the University of Manchester, I have visited his lab. Even he has a very big lab, and I would like to suggest the participants who want to visit in Manchester, they must see the lab of Dr. Lee. That is very big, means it has 3-4 RTDS, I think so, Dr. Lee?
Yeah. For six
lab.
Yeah.
It's not a small one. Means 4 RTDS means you can understand in what would be the size of the lab for this. And Dr. Lee has very high-level projects from the government of UK and other governments. And Dr. Lee, I remember one thing. We were working on a paper and he forgot that paper, and because that time there was some call for the project, he focused on that. Oh, Rajiv, I'm too much busy that time. First of all, because the deadline is going to close. So Dr. Lee is not only achieved this designation easily, he has continuously worked for that, and that work is too hard he has done. And I got the feedback from his research scholars as well. They also sit a lot of time inside the lab. They work very continuously and very hardworking. The scholars he has in his lab. So I am very humble to you as due to some problem in the network presentation get interrupted, but you started again on my request. It is really great about you, Dr. Lee. Thank you very much. Thank you.